Okay, we're going to begin our discussion of Chapter 2 with Problem 2. This is on page 59. And Problem 2 says, Julie drives 100 miles to grandmother's house. On the way to grandmother's, Julie drives half the distance at 40 miles per hour and half the distance at 60 miles per hour. On her return trip, she drives half the time at 40 miles per hour and half the time at 60 miles per hour. A, what is Julie's average speed on the way to grandmother's house? And B, what is her average speed on the return trip? Okay, so let's start out with what is average speed. And the average speed is basically the total change in the distance over the total change in time. So by changing whether or not we're going half the distance versus half the time, we are probably changing the average speed. So let's start with A, and A asks, what is Julie's average speed on the way to grandmother's house? So we're going to start with what are our givens? Okay. In this problem, it's on the way to grandmother's house. The total distance, so delta x, is going to be 100 miles. And then we're told that she drives half the distance at 50 miles per hour. So our average velocity for part 1 is going to be, 40 miles per hour. And our average velocity for part 2 will be 60 miles per hour. And then since we're going half the distance, we're going to basically call x1, delta x1 is going to be 50 miles per hour, or 50 miles, sorry, and delta x2 will also be 50 miles. So, and what we want to find is we want to find the average velocity for the whole trip, so just be average. Okay, so we're going to solve this. And the first thing that I recommend you do, and I'm going to keep reiterating this, is draw a picture. Okay, so we're going to draw a picture. Okay, so this is home. And by the way, I failed art class, so, don't expect much out of that. So this is Julie's home. And over here we've got Grandma's house. So this is Grandma's house. And the total distance between the two is 100 miles. So I'm guessing Grandma either lives in Bismarck or Fargo. Now we're told that half the distance, so this is going to be delta x1, is 50 miles, and delta x2 is also 50 miles. And I know you're sitting here going, well, the average velocity of the two should just be the average of 40 and 60. That's not the way it works. We have a definition for our average velocity, and that's what we have to use to solve this problem. So, that means what the real question is if we're looking at the velocity equation, we know the total distance, right? The total distance is just going to be our 100 miles, but we don't know how much time she spent in each half. So I'm just going to say that this is 40 miles per hour and V2 is going to be 60 miles per hour. Okay, so we don't know how much time she spent at each half, so we really can't solve this problem quite yet. So the first thing we're going to have to do is first find delta T1 and delta T2 so that we can find the total time, which is basically going to be the sum of those two times. Okay. All right, so let's start with finding the time for section 1. Okay, we're just going to use our average velocity equation that we have up here, and we're just going to use it specifically for the first leg of the trip, and we're going to rearrange to find delta t. So delta t, well, if we multiply that both sides by delta t, we end up with delta t on the left, and then we're going to divide both sides by v average, which gives us on the right side delta x over the average velocity. Okay, so for the first leg of the trip, that's going to be 1. This will also be 1. Okay, so that's going to be 50 miles over 40 miles per hour. That means that the first part of the trip, let me make sure I've got my numbers correct here, is going to be basically 5/4 of an hour. Okay. So now we're going to find delta T2. Okay. Let me pull up my okay. The next part is the same way we're going to look for delta 2. That's going to be delta x2 over the average velocity for the second part of the trip. So again, that's 50 miles over 60 miles per hour, which basically means that our time there is going to be 5/6 of an hour. Okay, so now we can find the average velocity for the whole trip, and that's going to be the total distance divided by the total time. Well, the total distance we know is 100 miles, and we're going to sum our times from both of these. So we're going to have 100 miles over 5/4 hours plus 5/6 hours, right? If I plug this into my calculator, that gives me about 100 miles over 2.08 hours. Okay, and that means my average velocity for the whole trip ends up being 48 miles per hour. Okay, so no, we can't just average the two values together, because it took, by doing different legs of it at different speeds, that changed the overall time from what we expect. Okay, now in the second part, we've got a slightly different scenario. Okay, we've got Julie's house here, so this is home, and this is Grandma's house. I'm not going to draw the houses this time. But we have one leg of the trip was done at 40 miles per hour. The velocity for the second part of the trip was done at 60 miles per hour. And in this case, delta T1 and delta T2 are the same. So the amount of time they spent in each one is the same. But the distances are going to be different, and we don't know how far she went in each of these legs. So in this case, we're just going to call this x1, and then we're going to say that x2 is actually equal to 100 miles minus x1. Okay? And the reason we're doing that is because we don't want to have two unknowns. We're just going to use one unknown, and that'll make life a little bit easier for us. So we're going to use our average velocity equation again, and we know that this is equal to change in distance over the change in time, right? But when we're looking at this, we also know that the times for each leg are equal. So if we rearrange this equation for delta t like we did above, we're going to have delta x is equal to v, or over v. Okay? So we can plug this in to this equation, excuse me, and we're going to have that the distance for the first part over the velocity in the first part is equal to the distance in the second part over the velocity in the second part. Okay? Well, the distance in the first part, we called that x1. The velocity in the first part was 40 miles per hour. Okay, that has to be equal to x2 over 60 miles per hour, but remember we said that we don't want two unknowns, So we said that x2 has to be equal to 100 minus x1 over 60 miles per hour. All right, so we're going to use these two terms. x1 over 40 miles per hour has to be equal to 100 minus x1 over 60 miles per hour. And now we're just going to cross multiply. So if I multiply x1 by 60, my left-hand side will be 60 times x1, and that'll be equal to the right-hand side. So we're going to have 40 times 100, that's going to be 4,000, minus 40x1. Okay, I'm going to add 40x1 to both sides. This gives me 100x1 on the left side is equal to 4,000. I'm going to divide by 100. And what this means is that x1 is equal to 40 miles. x2 is equal to 100 minus x1, so that's going to be 60 miles. Okay, so now we can figure out how much the total time was spent on each leg. Well, okay, we know the total time. So now we know the distance and for each leg. So we can say that the velocity for the whole trip is going to be the total distance, right, over the total time. Well, the total time, oops, I forgot to solve for the total time. We'll get back to this in a second. Total time for each leg, well, total time for one, that's going to be x1, which is 40 miles, over 40 miles per hour. So that's just going to be 1 hour. And time 2, well, that's just going to be 60 miles over 60 miles per hour. So that's also going to be 1 hour, which we knew because they were the same, right? So that means delta t total is the sum of both of these parts, and that's just going to be 2 hours. So when we're looking for our average velocity, now we've got total distance over total time. Our total distance is 100 miles, and our total time is going to be 2 hours. In this case, we get 50 miles per hour as our average velocity, okay? But in the first case, we did not, because the total time was not 2 hours. It was slightly different. So that's problem 2. Please let me know if you have any questions.